Okay, welcome everybody. I hope you had a good weekend, better than the Kansas City Chiefs had, since they got tromped on by the Philadelphia Eagles. And trying to make it so you can't quite see in that closet that much, but uh, anyhow, so welcome back. It's week 5, and let me share my PowerPoints with you. And let's see. So, in terms of announcements, uh, just a few announcements. Regular office hours. If you want to get in touch with me, no problem. I'm about done with using Camtasia and then putting my files up onto YouTube. It's a combination of my microphone still not working very well and when I use Zoom, I don't have to render them, and that takes a while. And so I think I'm going to just transition to using Zoom like this. It just works, so why not? Last one, I've added lots of examples of BigQuery-based projects for you. I know figuring if you're new, you have a new professor, and they give you this project, and it's hard to understand what exactly the professor wants from you in terms of project. So what I've done is I've tried to give you a bunch of resources, links, and things to so that you can be inspired to come up with interesting projects and something that I think will give you a kind of a bigger perspective on what your project can be. And let's see. So let me share that. So here's the examples for projects that I gave you. This was the first one, just a video about Brexit. Well, Brexit is a huge deal. A new survey came out, and people are trying to figure out whether more people regret leaving the regret Brexit or think it was okay. Well, this is interesting, and they use data to tell a story. The results of the survey are just one thing. The reporter in this case weaves the results of that survey into a story that's more interesting. All right, I'm going to pause here for a second. My dogs are going to go crazy in 1 second. Make sure I'm sharing what I think I'm sharing. Okay, so anyhow, so that's one, and then I also gave you a link to the Storytelling with Data, which is a really interesting company in that they offer tutorials and stuff to help data analysts do a better job tell stories with data. And I think that's a really powerful way to think about what your reports based on data really are. They're about stories. They're about communicating. And so this one has some really interesting videos and blogs and all kinds of stuff on there. So I think that would be very inspirational for you to take a look at it. I also included some projects from my visual analytics class last spring, and including, these are just interesting topics, and I think you'll find them very well done, very interesting. But they're telling a story, and they're trying to concentrate on how to present the data in a way that helps them communicate their ideas the best way possible. And I think you'll find that interesting. Another one here is a link to a New York Times newsletter called The Upshot. And the upshot is a lot of data stuff. They do a lot of really totally cool graphics and things in the upshot for the New York Times. And it's just, an example, and probably not a very good one either. But anyhow, so just to inspire you to go take a look at the upshot for the New York Times, and I think you'll find that interesting. Now, the last one that I've got here is a project that I had my students work on in ISTE 782. And it was about Chicago crime. Now, the Chicago crime really was a story about a real estate investment. And assuming I give you a background story, that says, well, we've got this international group of real estate investors who want to make a big investment in the Chicago area to build a new residential facility, whatever. And what I wanted the students to do was to do a comparative study of the culture of lawlessness that supposedly exists in the city of Chicago as part of an analysis of which ward, which political division in the city of Chicago would be the most profitable for this real estate company to make an investment in in Chicago. And the reason why I gave them this assignment is because I think it's realistic. Not many of you are going to end up working for the New York Times doing, the upshot graphics. But a lot of you may end up working for companies that are thinking about making investments in either new production equipment or new investments in new real estate or whatever it may be. But what you're using your analysis skills for is to present alternatives and to tell a story by presenting those alternatives. Let me show you an example of one of the student projects that that I was given in response to this, and a bunch of different things to take away from this. One, it looks good. They took the time to get their fonts right, to make the colors interesting, to give some background information about how nice the city of Chicago really is. There's a Chicago River. They turn it green for St. Patrick's Day, which is coming up. But there's this culture of lawlessness. People think about murders and things happening in the city of Chicago. Well, we've got the Chicago crime data set as one of the public data sets in BigQuery. And so I wanted them to find a way to use that, but not just counting crimes by ward. That doesn't tell it. That doesn't tell these investors what they need to know. What they're concerned about is not the count of every single crime that's out there. They want to know if we're going to make an investment in here, and there is this idea that Chicago is a lawless place. Well, how do we deal with that? And so the assignment asks students to use that Chicago crime data set to think about how to work with this data to present it in a way that made sense. A lot of students did like this, where they weighted different crimes, because in the data set, you get all of these crimes. Some of them are, awful homicides. Some are criminal sexual assault. Some are, all kinds of stuff. But some are jaywalking, walking across the street, not at an intersection. Some of them are, just silly things. Some of them are crimes of passion. Some are, they're all different. Of course, it's a big city. And so, how do you decide what weight should be applied to these different categories of crime? Because even here you can see that under the primary description of homicide, we've got 4 different categories. First degree murder, which is I think, when somebody says, I'm going to go kill that guy, let me go get my gun and I'll go kill him. Second degree murder might be, that is a crime of passion, something happened, we're on opposite sides of the Super Bowl or, whatever. Involuntary manslaughter might be somebody, hey, look at my new gun, boom, it goes off and kills somebody. They didn't mean to kill him, but that's what happened. And reckless homicide is probably something similar to that, although it may include things like traffic accidents where someone is killed accidentally. It's a traffic accident. And so, how do you those are not all the same. First degree murder is very different than a traffic accident. And yet, if we just counted homicides by ward, we would they would be lumped together. So, that was one of the challenges of this assignment. And what made it really good, because there's lots of different ways to do it. And then they, went through and looked at these crimes and stuff, and then they figured out, based on that, which wards were most interesting. They kind of took an initial cut at the wards that were most interesting, and that's fine, but there's more to it. Ward 42. We've got a little description of that urban appeal with challenges. Well, if you wanted to just invest in downtown Chicago, that's fine, but it's going to be very expensive. So maybe the right place to invest is not right in the downtown core, but outside the core. And then you have to think about, well, which ward is the best? And then you'd want to think about things, well, if people are going to commute to the urban core, how are the bus lines? How are the metro lines? How do you commute? What's parking like? What are real estate values like? What about the political representation in the different wards? Who are the ward leaders, I think it's called? And just interesting stuff to try and think about, job opportunities, cultural amenities, transportation. These are all things that would influence people in making a decision. Do I want to move into this newly built real estate project? Well, if there's no cultural amenities, forget about it. But if there's an art museum just down the street, and there's, lots of jobs in the area, and the ward has, really good transportation to the urban core, then, people are going to be more interested in it. Parks matter. And all of those things. So, and then pricing. What are some examples of real estate in that ward? What do they look like? How expensive are they? All of those were factors that went into making a decision about which ward to invest in. Who has the better cheekbones and for the for the ward representative. And so, just interesting. So they came up with several different wards that they recommended. I don't remember how many I asked them to do, but they did that. And this would make a really good project, mostly because it gives you something to talk about in terms when you get interviews. People always ask, have you done any interesting projects? And if you were able to say, well, we did this analysis where we used data from several different data sets and went out to the public record and we did all this stuff to figure out, an investment in financial investment in real estate, that's a good thing to talk about. Because people want you to have some sort of domain knowledge that you can apply your data skills to. Just knowing how to do SQL queries, probably not enough. But anyhow, so this one's out there. You're welcome to take a look at it. And I think it's, really good example of ways that you can use your data skills to make a really interesting project. Okay, that's it for that. Let's go back. So lots of new stuff in the in my courses, for you to help you figure out what's going on with your project. So this is from before, no big deal. Also from before. But it gets at an important question that we have to deal with when we talk about learning about databases. There's two big distinctions between these two. When you start doing your big query stuff, that's going to be very different in terms of the data that you're going to be analyzing than if you were doing an e-commerce kind of thing or doing working on a database that's designed to keep track of business processes and business outcomes. So the big distinction in databases is this. Online transaction processing, which is what banks do, insurance companies do, e-commerce companies do, when they're keeping track of taking things from inventory and then selling them to customers. That's a very different database than online analytics processing, where you work with data warehouses, data mines, data lakes, data this, data that, to analyze the results of what's happened recently in the past around an e-commerce company or whatever. The kind of questions that you would answer in a transaction processing environment are things like, Josh Allen is our customer. He's made, 50 transactions with us, but in that 48th transaction, he thinks that he didn't get the right product, or it came to him damaged. So we need to go back to that 48th transaction and change it around and send him a new one and blah blah blah. An analytics process, the kind of questions that you would be interested in answering are things like, what are our best-selling items from inventory? Where are the customers who buy the product J97? Where are they coming from? Are they all from Latin America? Are they all from individual countries within Latin America? Or is it something that's just way more popular in the Middle East and the MENA region? And how do we keep track of the inventory levels that we have around the products that we have so that we make sure that we have enough inventory to sell to people? One of the worst things that can happen to any sort of e-commerce company is what's called a yeah, let me think about it. You spend all this money, you get a customer to come to your facility to buy something. They come, they have money in their pocket, they want to spend the money, they go to the shelves, and there's nothing there. That's called a stock outage. Thank you. It just takes me a couple of minutes. A stock outage. And a stock outage is the worst thing that can happen to any sort of a company that's interested in buying things, because they spent all that money to get that customer to come to buy it, whether that's online or brick and mortar or whatever, and they didn't have the item to sell to the person. That's the worst thing that can happen. So anyhow, online transaction processing versus online analytics processing. Transaction processing databases are going to have tons of tables, 100 different tables, one of which is a customer table. Then we're going to have an address table. Then we're going to have an inventory table. We're going to have an order table. We're going to have all of these different tables that are normalized, so they're as small as possible and contain the least amount of redundant information, and we use them to record individual transactions. Analytics tables are going to be really wide. They're going to have tons of columns. And lots of those columns are going to be filled with redundant data that doesn't really mean that much, but it's in there because what we want to do is that every, Sunday night or Monday night or something like that at 3 o'clock in the morning, we run a query against our transaction processing database where we gather all of these fields together and just plunk them into this analytics database that our analysts are going to use for the next week to answer questions about related to our past operations. Now, why a full week? Isn't the data old and stale and not useful? Well, it doesn't really matter for these analytics queries because they're not looking for absolutely up to date, the latest information kind of stuff. It's okay when you look at trends over time to have your data be a little bit old, as long as it captures the nuances that managers want to find out about the data. Most of the time, those analytics databases are used by analysts to create reports for managers to make decisions from. The transaction processing database, that's used by people like, the switchboard people, the data entry people who are interacting with our individual customers to find out about individual transactions. Very, very different. Now, because they're so different, I said at the beginning of the semester that the big challenge for your generation is not going to be doing things with data. It's going to be doing things at scale with data. Well, there's a big difference between getting to scale in an analytics environment versus a transaction processing environment, mostly because of this difference in the number of concurrent sessions. The reason transaction processing databases are so difficult to work with is that as you scale them up, the number of concurrent sessions that you have goes up too, along with the amount of data that you're manipulating. And that creates all kinds of problems because it's just a more complex environment. Data warehouses, on the other hand, you may, have millions of transactions happening, but you've only got 6 analysts that work with the data. So, and they're going to run 10 or 15 queries a week against this analytics processing database that they use to answer questions for managers. Very different environment. Now, they may be manipulating gigs and gigs of data, but it doesn't matter because they're only doing it, 60 times a week. And that's all the queries that you have to worry about. But in transactions, the transactions are happening fast and furious, 24/7, 365. And everything's up in the air all the time. And the database is constantly in flux. Not the same with our analytics processing databases. There, the data is pretty nailed down. We write those databases once, and then we read from them, like I said, 60 times a week. That's it. So very different issues of scale. And that's what I wanted you to take away from that. Now, when we start talking about transaction processing, we have to worry about this, normalization. And normalization is all about finding ways to contain all the data that we want, but with the least redundancy possible. So if you think about, redundancy, it can be all over the place. It can be redundant information. There's a chance for errors in data entry. If people have to enter, every time Josh Allen calls in to buy something from us, if people have to type in his address every time, they're going to make mistakes. And poor Josh, he's going to miss out on his order, and that's going to break his heart. He's got nothing else to think about in the off season here. But anyhow, so it matters. So what we're interested in finding ways to do is to come up with a set of rules that allow us to reduce the redundancy. If we're going to gather Josh Allen's customer information, his name, his age, his birth date, his address, his whatever. We only want to do it as little as possible. Now, a guy like Josh Allen, rich quarterback, he's got one name, he's got one birthday, he's got one um, set of demographic information about him. But on the other hand, he may have multiple addresses because sometimes he lives in Orchard Park, but he's a California boy, so you can bet he's not out there freezing in the snow right now. He's out in California and living large in not, hopefully not Malibu, since Malibu just burned up, but he's living large someplace out in California and having a good time and trying to stay in shape. So, when he calls to buy something for us, we have to ask him, what address do you want us to ship this to? He may have one official mailing address, but he may have two or three different shipping addresses, and we need to make sure that we ship it to the proper address. Each time because it's so expensive to get new customers, we have to advertise for them, we have to, solicit them, make them come to our website, do all that kind of stuff. That costs a lot of money. Well, our goal is that each time we get a new customer, we have that customer order lots of things from us, many orders from us. So each one customer, we want to have many orders. And in each one of those orders, we don't want them to just order one thing, one set of shoelaces. We want them to order 10 different things, set of shoelaces, some new boots, sneakers, tennis shoes, whatever it is that they want to do. So each order may have multiple inventory items in it. Well, that's setting up this environment where we have one-to-many relationships between the customer information. One customer can have many addresses. One customer can have many orders, and each order can have many items in that order. And so, if we were to type in all of the order information with each item that goes into that order, we'd have redundant information. And odds are good that we would end up messing things up, with our sausage fingers of typing all that stuff in. So the goal of database design when it comes to transaction processing is this. It's to store the most information in the smallest number of tables. And we do that through normalizing. Normalization is made up of kind of these four different steps, because it's really steps. You always start with step one, which is each one of the tables in first normal form? No, first normal form is pretty easy. The table's in first normal form when all non-key columns depend on the primary key. So as long as you have a primary key, you're in first normal form. Okay. Then you go on to the next step, which is to say, gee, if I'm in first normal form, am I in second normal form? Well, a table's in second normal form when all non-key columns depend on the whole primary key. Now, in other words, if a table with a simple primary key is automatically in second normal form, if you have a customer ID that you use to identify each one of your customers, boom, that table is in second normal form. On the other hand, if you used a combination of first name, last name to identify each one of your customers, maybe you're in second normal form, maybe not. It gets a lot more complicated. What about that order table? If we have an order ID associated with each one of the orders that our customers make, boom, we're in second normal form. And same thing with the inventory items table. If we have an inventory ID or a part number associated with everything that we have that we sell, boom, we're in second normal form. The next question is, are we in third normal form? If we're in second normal form, are we in third normal form? Maybe we are, maybe we aren't. Um, to get to third normal form, let's see, a table is in third normal form when all non-key columns depend on the key, the whole key, and nothing but the key. What that means is that if we have non-key columns, we have key columns, we have non-key columns. So if the way that we uniquely identify something is based only on that primary key, now, when would that be a problem? Well, it might be a problem if you had things like extra fields in that table that help to identify things uniquely, like the color field, or you may have uh, 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 you may have a primary key that has some special digits associated with it that means something. That's a bad thing. If we have a facility in Chicago and one in San Diego, and we manufacture parts at both facilities, and each part that we manufacture in Chicago, we put a C in front of the part number, and the ones in San Diego, we put an S. I don't know how to do S with my hands. S in front of it. That's fine when we first start doing it, but what happens when we have a strike in San Diego? So we ship all our production to Chicago, and then we're making parts in Chicago that have a part number that starts with S. That's a problem because it's not true. And so would that field be in third normal form? Probably not. Now, the last one is Boyce-Codd normal form. I say last one. There are other levels of normalization that you can go to, but most of the time, business databases stop at third normal form. If you're really lucky, you get to Boyce-Codd normal form. Most of the time, you don't, and third normal form's about it. But Boyce-Codd normal form is let's see, third normal form term non-key removed. So non in third normal form, we're looking at a non-key column that depends on other non-key columns. In Boyce-Codd normal form, each column stands alone and is completely distinct. There's no all of our brown parts have this inventory ID number associated with them, or they have this special digit. The last digit is B. That's okay in third normal form, but it's not okay in Boyce-Codd normal form. So how do you go about the normalization process? Well, you got three steps. List all the unique columns. And those columns can be simple or composite. Composite, they have two different components to it. Let's see, identify dependencies in the non-unique columns. Non-unique columns are either external to all unique columns or contain within a composite unique column. And then eliminate dependencies. So start with your first normal form and say, do I have a primary key? If yes, congratulations, you're in first normal form. Go to the next level. Are you in second normal form? In second normal form, we're looking to see if you have a primary key that is not a composite key. If you have a primary key that's not a composite key, boom, congratulations, you're in second normal form. That's how you work your way down through this. But as you do this, what you're looking for is, where is that uniqueness? How do we identify the unique items that are contained in this table? So That's a normalization process. There's good examples in the Zai book about this, and I think you'll find it pretty interesting. Um, and I hope everything's going well for you, and I hope I didn't go too far over today. So anyhow, take care, everybody. I'll talk to you later. Bye bye.